Good evening, everyone. Actually, we didn't see any participants still yet, but good evening to everyone who is watching this recorded version of the talk. Uh, we'll discuss the biomass conversion and biorefinery NPTEL course, and today is the third week discussion, in which I will cover the week 3 content as well as week 4 content. Third week content you already has the answers, but we'll we uh, again check that how that answer comes, and we'll discuss some important facts, important information on the week 4 content also, that will be useful for you to solving the week 4 assignment if you still now didn't get any answer for that. So I want to share my screen. Okay, so actually I am sharing my screen. uh, so today is the sorry, we just ignore the first slide. We'll discuss about the week 3 as well as week 4 content. So week 3 is a biorefinery, and week 4 is a pre-treatment of biomass. So week 3 and week 4. So what we'll cover today? So in the week 3 biorefinery, you already have the answer of the assignments, and in the week 4 we'll cover some important information provided by the professor, and which will be helpful for you to in your assignment solving if you didn't solve the assignment till now. Okay, so he's a Professor Kaustubha Mohanty from IIT Guwahati, and he is the main instructor of this course. So let's start. So again, my information. So I am a PhD student from IIT Madras. If you if you have any doubt regarding any of the assignment problem, or if you want to learn something more, then you can note it down my mail ID as well as mobile number. For your anytime you can ping me for regarding any of your doubts. Now we'll start. So week 3 content is a biorefinery. So what I am following, what we are doing, first every week we are covering two weeks content. One for the 1 week which you already have the answer of assignments, and another week where you still have deadline to submit your assignment. So this week 3 content we last time also covered. In that we just covered that which are the probable information which will help you to solve the assignments, and currently we'll see that where is the actual answer of whatever the questions was there in the assignment 3, and week 4 we'll see some information. As this is a theoretical course, everyone easily get to know the information of in assignments. Whatever the questions are there, everything will be there. Everything is there in the details which professor already taught. But if you want to discuss, if you want to revise, then this will be much more helpful. So as we started from the biorefinery, so what is the main concept of biorefinery? So it is a similar thing which we follow in the petroleum. As in the petroleum we have the crude oil, and from that by using the fractional distillation and some other methods, we'll get some different kind of products, whether it is in the whether it is in it is as a fuel and energy products or some chemical. So similarly biorefinery is the same thing, where we use a biomass to convert it into the fuels and energy, as well as we are getting some chemicals which are important in our daily use or sometimes in the industrial use. So that's why this is a simple concept. And in the information of biorefinery itself, it is mentioned that biorefinery is probably the new concept for everyone. So there are many definitions of the biorefinery, like separation of biomass into distinct components using some thermochemical, biological or chemical method or treatments. So in that there is international energy agency is there, which will be take care of all the kind of different energy resources. So they also defined this biorefinery in their terms. So they have different task force for the different source of energy. For the bioenergy they have the task 42. In that they defined that biorefinery as the sustainable processing of biomass into spectrum of marketable bio-based products and bioenergy. So who just joined, will cover two contents, week 3 contents, which where we will understand where these assignments answers are there in the content, and week 4 content we will go through some glimpse of the content where you will get some answers of assignment for if you still didn't get it. Although it is easy to get these answers because totally theoretical course, but yeah, we can discuss. The revision is also taking place. So this on this definition itself there is one question in the assignment, that who defined the biorefinery as the sustainable processing of biomass into spectrum of marketable bio-based products and bioenergy. So there are some important points we can take care of our future learning, that it is a marketable will get as a product two things. One is a marketable bio-based products as well as bioenergy. So people mostly majorly focus on the bioenergy. Multiple of the amount of time we also see that biomass will be converted into the biofuels, but the major chunk of the biomass will be you will get it as a bio-based products. There are various chemicals or various materials which you can use the for your industrial purpose or the residential purpose. So here the question is like that, who gave this definitions? So as we just saw, this definition is given by the International Energy Agencies in Bioenergy Task 42. So here is the answer. And I am not following the sequential questions as in assignment 1, 2, 3, 4. I am following the content, and according to the content, whatever the questions will become, I will sort it. Will not go to the each and every detail of the week 3 in this discussion, because we already went through in the last time. So now the biorefinery, this same IEA task 42 gives some because they use many words which we don't have the exact meaning. So they define the words. What is a biorefinery? How actually what are the different words you need to understand for the understanding the biorefinery? Then sustainable processing, biomass spectrum, marketable products. Everything they explain in detail. So this is a standard definition. So if you don't know any word of the standard definition, then also it will make the some confusion. So they also define all these keywords. Now the basically biorefinery concept, as we see, it's it is mainly pre-treatment technology, and out of that some processing part. So we have the biomass supply. It needs to be sustainable. We need to get a biomass throughout the year or throughout the some significant amount of time, and then we go into the pre-treatment technology, which is the discussion of the week 4, that what are the different kind of pre-treatment technologies are there. Out of that you will get a different kind of components of the biomass which you can able to separate it out, and from that component you will get the final products. And as we already discussed, this final products, whenever we are using this whole set of biorefinery concept, whatever the final products we are getting, whatever the waste is generated in these final products, it needs to be again and again we need to go for the backward integration, that whatever the waste we'll get in the final product, we can again is use for the processing of products. If you are getting more, then we can again go back to the bulk chemical material production, and again or at the end we can again go back to the pre-treatment stage or wherever. But our whole, so whatever waste we are generating, it needs to be circular in the economy. It needs to be not go out for the dumping yard or some landfill or all. We don't want to spread the waste by using biorefinery. So it is a greener approach. Okay. So there is another questions in the assignment where they have the same IEA T42. What are the 4 features based new biorefinery classification approach? So actually there are many kind of different classification of biorefinery we saw last time, that based on the biomass, what are the different kind of biorefinery, based on the principles, based on the uh, type of technology they use based on the product. There are many different approaches we can classify the biorefinery. So, but if you see this T42, IAT42 use the four main features of any biomass technology or biorefinery technology for classification of the biorefinery. So here you can see that one is a platform, another is a products, feedstocks, processes. It is not in simple, but if you can see feedstocks, what are the raw material you are taking, processes, which kind of processes you are going for, the physical, chemical, thermophysical or mechanical, any kind of thing, platforms, which kind of as depending on the biomass we are using some technology, so which kind of platform is there, and products, final products. So it is a biochemical, it is a biofuel. So that is a four main classification approach, and it is also answer is here, that here the question is that which is not considered in four features. So as we know, so here quality is not considered as a four features in this classification, so we can give it, we can give the quality as an answer. Now types of biorefinery. So we'll not go into the much detail, but there is two questions are in this concept of types of biorefinery. One is a green biorefinery and one another is on marine biorefinery. So we'll see that which biorefinery use wet types of biomass and extract juice from the biomass. So there are four options: conventional, thermochemical, marine and green. So these are the some slides, or maybe these are the this is a definition of green biorefinery, and these are the different biorefinery types and their features. So if you don't want to go to much detail, but if you can see that for green biorefinery it mainly uses wet biomass, and now it's not like that it is only used wet biomass. Maybe there are some other biorefinery, thermochemical biorefinery also use wet biomass, but there is another thing that it has also used juice from the biomass. It is not mentioned here, but when you go for the green biorefinery concept, then this is a green biomass. It is this green biomass needs to be pressed, and after pressing you will get some amount, some kind of juice. So, and it is mentioned everywhere. So that's why we can consider this green biorefinery with the answer, which can use the wet types of biomass as well as the juice. So it is converting into the cake and nutrient rich pressed juice. So it is a cold press kind of thing. Whatever biomass you will get, it will convert into juice, and from the juice it is easy to react liquid then solid. That's why they converted in solid into the liquid, and then they go for the next step of their processing. So this is the one thing. If you go for the another questions, and that question is based on the marine biorefinery. So we don't want to, we will not go into the much more detail. So but if you can see that this is aquatic biomass, which we are getting the biomass from the marine ecosystem, like microalgae, macroalgae, some different kind of vegetables which we have found are under the sea. So and that after that, if you there are two different ways. You have to use sunlight, CO2 nutrients and fertilizers, and you will react for the transesterification, you will get some product. You go for the extraction of acid and purification, and then this oil fraction you will get some products. From mineral you will get some products. From carbohydrate fraction, with the fermentation you are getting the fuels and chemicals, biofuel, mainly alcohol based biofuels. If you get the protein out of it, you will get the value added products. So now the question is, which biomass is not considered for the marine biorefinery? So microalgae, algae is always into the marine environment. Macroalgae is also a marine environment. Micro and macro is just the size difference. So if you have the algae which is very small, in the 10 to power minus 6 meter in the range, and if you have algae which is a little bit bigger, and it is a dimension of 10 to minus 3 meter and more. So it is in between this. So this can be going to the micro, and another is going to the macro. And another two questions, under two answers are seaweed and lignocellulosic biomass. So from question itself we can get that seaweed, it's one kind of vegetation which we found under the sea, and lignocellulosic biomass is the biomass which mainly we got from the hardwood, so which has lignin as well as cellulose, hemicellulose in the adequate amount. So definitely we will not get this lignocellulosic biomass, we will get this we are not using as a biomass into the marine biorefinery. And in the explanation of marine biorefinery, it is clearly mentioned that by professor that it can be microalgae, seaweeds, macroalgae, and whatever it is, other than anything which will come out of the sea. Now we don't go into the much more detail of the biorefinery process classification. There are four major there are four biorefinery classification as we saw. One based on the process, one is about feedstock and platform and all. So if we go for the process classification, then one is a mechanical physical process. We can press, pre-treatment, milling, separation, distillation. This kind of mechanical physical process are there. There is no chemical reaction is going on. Another is a chemical process, which is a hydrolysis, transesterification, hydrogenation, oxidation, pulping. This kind of chemical reactions, which will be also give you some products. If you go to biochemical, where you perform some chemical reactions in the presence of some bio-based materials, basically microorganisms or enzymes. Microorganisms are living entity, and if you extract the enzymes out of it, and you can directly react with biomass. So that are some mainly the fermentation kind of process. Aerobic, anaerobic. Aerobic is in the presence of oxygen and air. Anaerobic in the absence of oxygen. Anaerobic digestion process, enzymatic conversion process. Chemical, we already see thermochemical. In thermochemical, it's a chemical process, but it required a very high temperature. So temperature is very high. So that's why you can see the pyrolysis, gasification, hydrothermal upgrading and combustion. So you operate this kind of process more than 300, 400, up to 800, 900 degrees centigrade. So these are the example. Now why we again visited this concept? So because there are two questions on it. One is which one of the following describes the treatment of biomass by chemical process. So there are hydrolysis, transesterification, hydrogenation, all comes under the chemical processes, as we just see. So that's why we can correct answer is all of the above process is using the treatment of biomass by chemical process. Now another is on the thermochemical process. So which of the following is not a part of the thermochemical process? We already see hydrothermal liquefaction, which we all this process will see in the future in detail that how it will take place. Supercritical some process. Supercritical is not only supercritical, it needs to be supercritical fermentation, supercritical gasification kind of process, gasification, and all this may be converted to thermochemical, as we know. But you can see that pulping it not cover in this thermochemical category. So pulping will be the answer of this question. Now some questions are based on in the fourth assignment also some questions are based on the fundamental part of the biomass, which is cellulose, hemicellulose and lignin, and some questions in the assignment 3 also based on this. So mainly we can see that organic matter, any organic matter including human beings also, if we can extract the component out of it, so but humans are not always we will not get the carbohydrates from the we will see the carbohydrates, but not exactly same carbohydrates we are getting from the biomass, or maybe you can say the vegetations. So carbohydrates are nothing but the C and H compounds. So in human we have more glucose and all, but if you go to the vegetables and all, you will get this in the biomass and all, you will get this cellulose more. So we don't have that thing, but we have more complex biomass organic matter inside the human beings. But if we just focus into the organic matter of the plants and different kind of biomass, then it's mainly carbohydrates, proteins, lipids and nucleic acids. Okay, so in that also mainly carbohydrates are which are the combination of carbon, hydrogen and oxygens. Oxygen mostly present. Carbohydrates is the carbon and hydrogen, but oxygen is also present in significant amounts. So we know that we have the cellulose in every biomass. Mostly we have the cellulose if it is comes from the vegetables or if it comes from the trees and all. So cellulose is nothing but it's a polymer of different kind of C and OH hexamer. You have C, OH, and like we all know in chemistry. So maybe here we have OH and H. So this is a one like this 6 carbon chain are there. Sometimes OH is there in this. You need to go for the actual version. And this is converted into the glucose. Then this glucose will be as a monomer come together in the long chain in the polymer. It is a cellulose. So that's why, but cellulose mainly consists of the saccharides. Saccharides is the sugar compound, or saccharides is come from the obviously saccharides is a class of compound where it will mainly consist glucose, fructose, many pentose, any hexose. So here one saccharide is known as a monosaccharide, and two saccharides come together, it is known as a disaccharide. So we all know that glucose and fructose all are monosaccharides because their formula is C6H12O6. But two glucose come together, or you can say that one fructose and one glucose come together, and you will get they come together in the sense one of the bond of from two, one bond can be break and they can connect it. So that's why one H oxygen is lower than the both of that. In these they have 12 oxygen, and this is known as a mainly sucrose, which we are using as a sugar. So it is mainly disaccharide, and these are the monosaccharide. And if you go to the cellulose, which has a long chain of this thing, so it is known as a polysaccharides. So these are just there is one question. So, and maybe I am thinking that the answer is not right. So sucrose, sugar, considered as a monosaccharide, and disaccharide, tri or polysaccharide. So according to me, disaccharide is the answer, and you can also see that sucrose is a disaccharide. It is there in the professor's slide also. So but here answer is mentioned as a monosaccharide, so it is not a right answer. Obviously it is a very easy, so we can predict that it is not a right answer, but it's fine. So maybe I will communicate if possible to the TAs of the professor to take care of all this during the exam and all, or in the assignment if they can able to do something on it or not. So last time also we found two answers are not exactly match with our prediction, and this is definitely wrong answer. So we can talk with maybe I will try to talk with them. Now another thing is the lignin, that we all know that there are mainly three chemical which we have interest. One is the cellulose, hemicellulose, and lignin. When in which lignocellulosic biomass, if we talk about lignocellulosic biomass, which is a hardwood base, so it has a cellulose in the major part, but it is also depends at which is the type of biomass. Another is a hemicellulose, and another is the other part is lignin. So this green is a cellulose, hemicellulose is also in with that, and in this you will see the hard sticks kind of structure from the lignin. So if you talk about lignin, it requires strong acid or bases or other hydrothermal treatment to be hydrolyzed. So what is the hydrolysis, which we'll see into the pre-treatment process in the coming slides in detail. So we have to remove all these three things because every different component has a potential to convert into the final products. So that's why we need to do some treatments, so we can separate it out. And cellulose and hemicellulose is important part of the compound. We have some other products, and lignin may be also converted into some products. So here the answer is strong acid and bases we have to use for the lignin hydrolysis. And there is one question, so which requires strong acid or bases other has hydrothermal treatment to be hydrolyzed. That is answer is a lignin. So this is the answer. Now on the chemical composition and characterization of biomass, there is two questions of this information. That's why I put this slide again. So elemental composition of the biomass is mainly, you can see carbon is in the major part 42 to 47, and the similar part is about oxygen, and 6% of hydrogen or percentage in the dry matter. This is the plant biomass, okay, mainly. So this elemental composition of biomass is followed by this is the main thing. So 40, 40 and 6, roughly if we consider 42, 45, 45 and 6, around 96%, and after that also we have lots of amount of chemical inside it. So after that, whatever the remaining chemical in this, there are three different category. One is a macronutrients, another is a micronutrients, and another last one is the trace elements. So what is the macronutrients? Which will be present in the larger amount. So that is a nitrogen, phosphorus, potassium, calcium, magnesium and sulfur. These all are the important metals. So in the form of nutrients it is present. Other is a micronutrients and trace elements. So you can see the that what are the chemical which is present as in this category. So sodium, chlorine, iron, manganese, copper, zinc, molybdenum, nickel, selenium and silicon. This summing all up to 4%. And it sometimes contain other chemical other elements of metals also. But our question is, which content is most abundant in the plant biomass, which is the carbon, as we can already see that more than 42 to 47%, in between in the range of 40 to 46%, and which is not considered as a macronutrients for the plants. So boron, so you will not find the boron as a in any list. You will not find the boron. So boron will be not boron is not available in any kind of biomass. So that's why the answer is boron. Now this is the last slide of the week 3, I think. Yeah, after that we will discuss about the week 4. So in the week 3, the last part of the week 3, where professor discuss about the different types of biorefinery features and life cycle assessment. Also he life cycle LCA is also in economics, and also everything also discussed. We don't need to go to this thing, but yeah, these all things will be important to understand the concepts. But if you just see the biorefinery type and their features and products, then this is based on the biomass or feedstocks which we are taking. So if it is agricultural biorefinery, then you can get the biomass, will use it biomass of agriculture activities and waste generated, but you will get a product as a methane, nitrogen, biofuels and many chemicals. So this is the most preferable lignocellulosic biomass and biorefinery. Why? Because in the worldwide people are using corn, bagasse and different kind of biomass generated from the rice and wheat. So this is mainly comes from the agricultural. Then the cereal biorefinery, which has starch crops, sugar crops and grains. It is only give you one major product, which is a bioalcohol, bioethanol. Oilseed biorefinery, we have many different kind of oils, chetropa oil, sunflower oil, and these are kind of oil we can use for the, and all that's vegetable oil we can use in the refinery. Biomass we can use, and from this oil seed and oil plants you again get the vegetable oil as well as biodiesel. Green biorefinery we discuss, green and green plants we convert into juice. You get the bioethanol as the main product. Lignocellulosic biorefinery, so this is agriculture also has lignocellulose, but this specifically lignocellulose biorefinery, it is also from the agriculture and sometimes a crop residues. But this agriculture, maybe we are doing the agriculture of some crop just to use for the as a in the biomass in the biorefinery, but this may be the waste material, mainly the waste material, or some power crop, energy crop kind of thing. It is also get bioethanol. Forestry biorefinery, in the forest we have the hardwood, dust, pulping, liquors, fibers, everything is there in the forest biomass. You will get fuels, energy, chemicals and materials. Industrial municipal waste, which is the problem of the major cities, that you can convert into the methane, hydrogen, fuel, energy, chemical. So this is a broadly, there are, depending on which process you are using, which pre-treatment process you are using, which final chemical reactions you are using, there may be differences on the product side, but majorly you can make this kind of products. Okay, so now we can start the week 4 discussion. And I want to tell you that I will not cover the direct exact answer of any of the questions in the assignment of week 4, as the deadline is tomorrow, but I will cover the major part of the week 4 discussion, and it will be helpful for your good precap kind of thing. Another thing is that week 4 is, there are too much amount of information. If you just so the videos, or if you just go through the materials which are circulated by the professor, there are many different kind of processes are there, many things needs to be understand. I am not telling that needs to be remembered, because no one can remember all these things, and but professor give you so much amount of information, and that will be helpful for you to understand the actual processes. Why? Because he used the journal papers, so he used research papers as a information, the details from the research paper. So you will see that actual research papers, and people are doing the work, and what is actual amount of product you are getting, bioproducts or biofuel you are getting from the particular biomass, and which is the technology they are using. Many information is there, so don't worry or don't afraid of after watching this many information, or so don't worry, it will be not in the direct exam, but yeah, that is for information to understand the things. Now, so barriers in the lignocellulosic biomass conversion. So I am covering the slides. If you just see this, then okay, so someone just joined. So I am just telling that we just covered week 3 discussion of all the questions and where it came from. So already we have answers. So where we got the answers, so we from the professor's slide we saw. And in this week 4 discussion is just started. This is the first slide of week 4 discussion, and in this we will cover that main information which will be helpful you to get the solution of your assignment answers, and this will be good pre-cap of all these things. And as I told that there are so much information in week 4, we will not cover all these things, but it will be helpful for you to understand that what actual people are doing on the research base, on the commercial level, which is the technology which are going to help. So every slides here I am explaining for the week flow. It has some connection to the assignment questions, but I will not tell you the exact answer which questions I am targeting on these slides. So we start with the lignocellulosic biomass conversion. So the major part of the biomass is as agriculture, as well as any forestry or mainly energy crops or everything. It has the plant based biomass, so it has the lignocellulosic biomass. Lignocellulosic means it has the cellulose inside it, and it has the lignin also. So cellulose is also covered, hemicellulose, and there are questions based on that also. So what are the barriers? Now we need to understand. Lignocellulose is the most abundantly available, inexpensive, and a renewable raw material. We all see. I didn't cover many outside of the. Generally, I put the slides which are not covered by the professor. I took from the internet or not. But in this, because there are so much information, mainly I focus the professor covered the main thing from the professors. Now, lignocellulosic biomass is being invested as a promising technology, a promising field for feedstock. Why? Because in US and everywhere you see that corn, sugarcane, and in India also they are started from the wheat and rice kind of biomass. So it is the main promising feedstock for the products of many fuels, chemical as well as materials. Now, products of commercial valuable chemicals and biophysiologic lignocellulose based processes has the potential to decrease greenhouse gas emissions. So these are some important advantages also, bring benefits to rural economics and promote energy security. The composition of lignocellulosic biomass varies with the biomass source. So you need to understand that every time you will not find this much amount of cellulose, this is hemicellulose, and this is a lignin. Depending on the source, depending on the origin, depending on the how much time it already lifetime of this particular biomass. Suppose you have the green biomass for a green biorefinery, which is only week or month old, and if you have the biomass from the agriculture crop waste, which is 4, 5, 6 months old, so depending on the age, climatic condition, you will not find the similar kind of composition of biomass from here and maybe in the western countries. So which kind of harvesting processes are there, which part you are considering, which kind of storage you are taking, so all this will be impacted in the final composition of the biomass. So you always need to remember there are many parameters which will be finalize our biomass characterization. Now chemical composition of lignocellulosic biomass we cover in the last class in the victory part also, and here also we will cover. We will not go into the detail, but yeah, there are three major parts. Actually four other parts are the extractive materials, but majorly we have cellulose 30 to 58%, hemicellulose and lignin. So there are questions on based on this in the assignments, so that's why we'll little bit go into the detail, understand a small part, and that will be helpful. So these are many kind of tables are there in this particular week, so I'm telling you, you don't need to remember all these things, but these are the very good information for you to understand, because these all tables are come from the research papers. So they are very recent research papers, you see 2020, 2019. So these all are the current research which we are going. So why professor included all these things, why in this particular subject all these things will be important. So this will be important for people who want to go into the some kind of research or want to understand the actual part of the thing, want to have some in the future, if you are targeting to go to in this kind of sector or something where we are using this maybe in your research as a student, as a independent organization, or if you want to go for the startup also, because if you go to Europe, basically there are many more startups, Netherlands and Norway, which have worked on the biomass to biofuel conversion. So this will be one proper sector of revolution also you can consider, where you will go for the startups and work. But currently why we are not getting so many startups on this, because currently whatever products we are getting as a biofuel or biodiesel, any kind of products, bioethanol, or if you consider any kind of product by using fermentation and all, these are much more costly than their commercial availability currently in the commercial available value in the current world. So that's why people are still using the conventional processes, but we have this net zero carbon emissions and all in this Paris agreement, and after this in COP26, and also people are eventually COP27. So people are eventually, so again someone just joined, so I'm just telling that we cover week 3 content and their answer assignments, questions and answer. We just started week 4 discussion. In this I will cover the main slides where you have the assignment questions, and this will be good recap for the information. If you want to discuss anytime, you can discuss on anything. I will not cover everything because so much information, but it will be helpful for you to understand the things. So yeah, I forgot where I was. Anyway, so we'll just see that in the link. So conventionally whatever products we are getting from the chemical reactions, these are still cheaper from this biomass conversion to the fuel or biomass conversion to chemicals. That's why currently you will not getting many kind of technology development and all. But once every country will be emphasized to go to the net zero emissions and all, so they need to go for the sustainable solutions for all this, and for them this competitive market will become, and this all technology of biomass conversion will be lower, expensive will be lower down. And I just want to tell you one more thing, that in the assignment 3, that sugar question, it is disaccharide, and it is mentioned as a monosaccharide in the answer, but answer must be disaccharide, that's it. So the lignocellulosic biomass has cellulose, lignin and hemicellulose, but it is like that outer layer which is mainly the cell wall, which mainly consists lignin. Inside you will get these polymers of cellulose as well as hemicellulose. So first of all, you need to first you're going to go for the composition, that cellulose, hemicellulose and packed by the phenolhaldehyde lignite polymer. Everything is polymer, nothing is the single molecule. If you see the human body, we have proteins which is a polymer from the amino acid and many things. So that's why everything is in the long chain form. The polysaccharide fraction of lignocellulose biomass, including cellulose, hemicellulose, can be broken down into sugar. So cellulose has the glucose in the long chain of glucose. Hemicellulose has many different kind of material which is in the chain. So if you can break it down, it will be converted into sugar, and then we can go for some alcohol base of chemical out of it. and then they are converted to biofuels, biogas, biochemical, or many things by many methods, anaerobic digestion and fermentation. So this is again in the layman language. If you just want to understand, yeah. If someone has any questions, so they can ask. Okay. So we don't need to go for the which is the structure of any kind of pentose and hexoses, but yeah, if you just want to remember the name, so mainly we glucose we are plotting like this into the chemistry, and this 6 some and because depending on to the one side H and one side OH, depending on to the OH side we go for the D glucose, L glucose. So this is the same thing. It is just represented in the different manner, and there is at the end one O is there. So similar, if you go same, all the glucose are there, then it is a cellulose. But you have some pentoses. Glucose is hexose, means 6 carbon is there, and if you have 5 carbon, it is a pentoses. There are some examples: xylose, arabinose, and some hexoses: glucose, galactose, fructose, mannose, many things. The list is gone. So if it all are combined together and make one polymer, it is a hemicellulose, and this is a lignin. Lignin means mainly aromatic alcohol kind of thing. So maybe names are obviously difficult. So coniferyl alcohol, comeryl alcohol, and maybe I am also pronouncing wrong, but this kind of aromatic alcohol comes together and makes some polymers, and it is a lignin. And we all know that this is a biomass. If you just take one cell of biomass, and if you again zoom it out, you will get this kind of in the cell we have some liquid material. In liquid many things are there. If you zoom it out, so the first thing you will find, this is extractives. So these are some organic molecules are there in the cells to perform some amount of work into the biomass cell. And again you will zoom it out into a small part of this yellow thing, then you will see that it has a fibers. So all the microfibrous structure is there. So in these fibers you will get the lignin, hemicellulose, and out of that one major chunk of material is there. If you again zoom it out, it is also as a combination of the hemicellulose and cellulose, but outside layer is lignin only. So I am just covering the small portion of what is cellulose and what is hemicellulose. We already covered. So the cellulose has a composition which is varies. Obviously the composition of lignocellulose biomass which varies based on the species, age, stage of growth, and many more reasons which we can consider. But it is a polymer composed of the D-glucose. So D-glucose means its first OH is the right side of carbon. So you don't need to go for the D and L thing into nature, but yeah, but it is linked together by beta 1,4 glycosidic bonds. So what is it? So if you can see the one number of carbon of one glucose molecule and another 4 number of carbon of another glucose molecule and combined together, as they have both have H as well as OH. If you just want to understand the things how it will take place, so they have H and OH. Okay, so now if both of them are combined, so this H and this OH will be, you will get the H2O, and this whole O is combined like this, and this will be the, say, as a beta 1,4 glycosidic bonds. This is known as a glycosidic bond. So you will get that H2O at the end in this polymerization process. So the degree of polymerization is 4,000 6,000 glucose in woody biomass. So if you consider wood biomass, then you have 4,000 to 6,000 glucose molecule. And in the polymer, cellulose are interlinked through hydrogen van der Waals bond to form a microfiber and present in crystalline amorphous form. This is most important thing if you want to convert into the products. So because of van der Waals forces as well as hydrogen bonding and all, and in hydrogen molecules and all, they convert into the microfiber structure. This kind of small fibers are there, and in these fibers some part is a crystalline, so and some is amorphous. Amorphous is if you have sugar, so if you have sugar crystal, just consider this, and so many sugar crystals are there. If you provide the heat here, Then after some time you will get the semi-solid liquid, which is the amorphous and this amorphous state. This is the crystallization state, and at the end you will get the whole liquid kind of thing. Okay, and this is a crystallization is whole solid. This is a solid and liquid mixture. So this, if it is in condition of solid and liquid mixture, then you will easily react it with some other reactants, and you will get the product easily in this, because you will easily if you just because it is a liquid form, and liquid based reactions are always mass transfer heat transfer more in with respect to solids. And so that's why subcrystalline molecules are there. It will be very difficult to convert into the amorphous, and you convert into the products. And this crystalline cellulose fiber attached to the non-covalent. There are many information. Cellulase. Now the important thing is cellulase is the one enzyme which we can use to convert the cellulose into the we need to degrade the cellulose. So if we use this cellulase enzyme and fermentation process, then it is very accessible for the amorphous cellulose converted, and less accessible for the crystalline portion. As we discussed, very difficult to reaction in the form. If you talk the hemicellulose, then it has pentoses, xylose, arabinose, glucose, and hexoses, glucose, mannose, galactose. Not only this, it has some acetyl group, it has some uronic acid also, and it has 50 to 300 monosaccharides unit. It doesn't have 4000 6000 units. And hemicellulose has crystalline structure to its branch structure, and presence of acetyl group, and easily degradable to its amorphous nature. Owing to its it has two kind of structure again. Hemicellulose also crystalline structure because of presence of acetyl groups, and amorphous structure means branch structure. Okay, so branch structure, crystalline structure owing to its branch structure, and presence of due to branch structure it is a crystalline structure, and due to presence of acetyl group it is an amorphous and easily degradable. Hemicellulose acts as a physical barrier and restricts the accessibility of cellulose to cellulose. So these are the important thing. This is you can see that not only the 2-3 which we discuss, xylose and arabinose, there are many different kind of chemicals. Acetic acid is all. Just wait a second. Yeah, so acetic acid is there, so which is making the bond between the two different monomers. We have glucose, mannose, galactose, xylose, and now they reacted with each other, and they will convert into the different kind of organic molecules, carbohydrates also, and sometimes organic chemicals. So it convert to hydroxymethyl furfurar is there. It is a levulinic acid, formic acid. Many things are combined together, and it's like if in the simple word we have bell. So it has all different kind of things, and we'll get to know when we are tasting the bread bell, we will get the taste of each and every individual ingredients. Like this, they have many different kind of things come together in make the polymerization. So as a hemicellulose, depending on these components, they show some different characteristics. Once you hydrolyze it, you will get different products out of it. They will dissociate, and according to that product you will get final biodiesel. So all these things are much more important in the sense when you go to the much more detail of the chemistry. And this is a lignin. So lignin is the most complex amorphous polymer. Why? Because it has polyphenolic structures. So polyphenolics is, if we can consider, it has the aromatic carbon, and this is it is all in the form of alcohol, which we already discussed, and that alcohol in some or some of the other subunits are converted, and they come together like particular kind of alcohol, H, G and S. There are more H and G come together, S come together, depending on your biomass. Then you will give you the different kind of complex polymer which is as a lignin. So you can see it's a big maybe if you can't able to see, then it's a whole network of this kind of alcohols. But gymnosperms, so softwood and fern lignin are generally composed of G as the main component, and followed by the H. Now if you just see the softwood and all, So it has a G as a main component. And if you go for the another kind of biomass, it has like hardwood is mainly composed of S unit and then G. Now how they are linked together, it is a very important thing. They are linked together beta O4 aryl ether bonds. So how can we know that thing? So mainly whenever alcohol are come together in the polymerization, not whenever but most of the time, alcohols are come together and make the polymerization. So you can see these are two alcohols. So if you are come together, then definitely what is the product? One OH and H will be the product, as a byproduct H2O you will get, and at the end you will get this O, and two side you have two monomers. This is not only OH, there is some this kind of alcohol is there here also and here also, and then you will get this one of this side, one this side, and then the whole chain out of it. So that's why most of the time if two alcohol come together, you will get the final polymer in the form of ether. So this is your just for your just for your information. So that's why you have beta O4. So beta O4 means beta is the position of every monomer unit. There are alpha beta position they give. So like maybe the second carbon of every monomer is connected or something kind of this. Not is the position. Oh, sorry. Beta O4 aryl ether bonds. So okay, it's a type of bond where you have beta position as well as 4 position. Something is there. Maybe I will see if it is in there in the sub slides, or maybe next time I will come, because we will discuss the answer of the 4th assignments, and this is the important thing. So we'll take care of this thing, why actual bonds are taken place. Although this will be not that much important in your assignments and other thing, but for the learning purpose it is required. Now the important part of the 4th week of the work is the recalcitrance. Now what is the recalcitrance and why it is important and why we are doing the pre-treatment. So whole chapter of pre-treatment is mainly the major reason is the recalcitrance. So recalcitrance is nothing. In the simple word, if you are in the simple word, if I want to tell you, it may not be the correct, but if you want the understanding, so we have the lignin, or what you can say, cell wall there. Every plant cell has a cell wall. Recalcitrance is not some, you don't consider it as recalcitrance is the term just related to biomass. It is an English word, and recalcitrance is the like prevention or opposition, restriction, some barrier or something kind of thing. It is known as a recalcitrance. But you have plant war into all the biomass from the plant based or any wood based biomass or cellulosic biomass. So this wall is very difficult for us to access to the cellulose and hemicellulose part. So this wall will be the major part of recalcitrance. So you can consider that this is a barrier or resistance. So we can't go through this wall are there, and our main chemical are there. It's very difficult for us to break this wall and go to our final raw material to convert into the bioproducts. So this is one kind of barriers. And if you go for the which kind of chemical composition which we are using, if my voice is echoing, then also you can tell, or if you have any questions also you can write or you can mention. Jainath, do you have any question? Okay, sorry, by mistake. Okay. Anyway, it's fine, don't worry. So if you just see why this treatment method and all. So lignin is there. It is act as a physical barrier and restrict the accessibility to cellulose, but it derives some inhibitory effect on hydrolysis products also. So if it converts into some compound, because it is an aromatic hydrocarbon converted into compound which will be inhibit our biofuels or bio-based bioethanol products. We have hemicellulose act as a physical barrier and restrict the accessibility of the cellulose cellulase enzyme to go to the reach to cellulose. Acetyl groups, which you see, interfere with enzyme recognition by inhibiting hydrogen bonding between cellulose and catalytic amine of cellulose. Now this is the chemical recalcitrance or chemical barriers. If you go for the physical structure, you have proteins. Cell or proteins have positive and negative effect on hydrolysis. So crystallinity, we all see that amorphous will be the, if we get the amorphous condition or amorphous structure, then it will easy to convert it into the final product. But if it is crystalline, then 30 times hydrolysis rate of amorphous cellulose is 30 times higher than the crystalline cellulose. So if you have amorphous, then we can get the 30 times more productivity. Degree of polymerization, if you have a low degree of polymerization, then it is more accessible. If you have very long chain, then it's difficult. Particle size, if the particle size is reduced, then surface area is high, and we can easily get access to the final to the main important reactants from the biomass. Pore size is also important factor. So because chemicals and some cellulose kind of material will be going to some limited amount of pore size, surface area is obviously higher surface area, you can get higher hydrolysis. So what is a biomass recalcitrance? If you just want to understand, so the natural resistance of plant cell walls for its biological conversion mainly caused by the complexity and heterogeneity of biomass. So this is a simple example or simple definition. So don't worry, it is not very big thing, but all the plant cell has plant cell walls, and obviously as we human also, before that we have not developed a healthcare center, health medical facilities in our body. Also, if we are getting some wound or some pain and some pain and something is with there, so it will be automatically naturally also healed sometimes. So like these are the bio plants and animals are much more exposed to this kind of injuries and all these things. So that's why naturally they have this resistance, which is called as a biorecalcitrance. So calcitrance is a resistance, but biorecalcitrance, you consider it is a biomass recalcitrance, short form of biomass recalcitrance, and due to this organic complexity and heterogeneity of biomass, cellulose molecular weight, lignin molecular weight, lignin phenolic hydroxyl group, there are many things. So if you just want to understand the recalcitrance, so yeah, so whosoever currently joined, we are discussing the currently week 4 information. Week 3 assignment solving problem we already gone through, and here I will just cover the important part which will be helpful for you to understanding your assignment problem, and this will be helpful for you to just quick recap and for understanding if you find any difficulties. So this biomass recalcitrance, as we just for the newly joined person, it is a natural resistance of the plant cell walls. So plant cell has walls and it has a very complex structures, complex part, which will be now if we want to convert it into the products, then this all act as a resistance or barrier to us. So as you can see, which are the major recalcitrants? Cellulose is one of them. It is, if you have high molecular weight, long chain, it is a lignin molecular weight, it is also very high chain, it is also resistance. Phenolic hydroxyl group from lignin, it is a detrimental to our final products. Monolignol distribution I think. So monolignic amount are there. So basically they are the aromatic molecules. Cellulose crystallinity is there. It will take very low efficiency and will take much more time. Cellulose accessibility, if we have high accessibility, we can get products very easily. So this is all about the recalcitrance. So if there are some questions is there in the assignment, if one or two, then you need to give the answer. If you still didn't understand, because in the 4th week all the questions are easy with respect to other. So pre-treatment of biomass, now why it is important. So just a second, I just want to take some sip of water. So we all see this biomass has mainly 3 components: hemicellulose, cellulose, as well as lignin. I am talking about the lignocellulosic biomass, okay, mainly the agriculture and forestry and all. So these are the lignin, and this straight one is the cellulose, and then you will see it's in uh, some ununified structure. It is a hemicellulose. So now if you want to use this hemicellulose and cellulose part, then we have to break it down. So for the breaking, we have to go for the pre-treatment. So pre-treatment, mainly hydrolysis is the one of the option. So where we need to break down the biomass. Now though, if you understand which are the criteria to reach to an improvement in hydrolysis of lignocellulosic material. So after hydrolysis you will get uh, separate of hemicellulose, cellulose and lignin, all things needs to be separated, and there are different kind of products which you will get from every materials, which we'll discuss in the some couple of slides. We don't have to discuss many slides, maybe in next 6, 7, 8 slides, that's it. So because there are many much information in this week 4 content, these are helpful for you to understand the concept, because there are research paper data and all, but you don't need to remember each and everything, but we can't cover everything in this one session. So which are the important criteria? Just go through. Increasing the surface area and porosity, we just discussed 1-2 slides back. Lignin structure needs to be modification is required. If you all these things are there, then we can easily hydrolyze our lignocellulose. Removal of lignin, obviously lignin is the major barrier, because it has two thing. It is not reactive with the our chemical procedure which we are using for the hemicellulose and cellulose. Other thing, it is reacted, it is not exactly we are not getting some product out of it which we want from the cellulose, but it is reacted and it is making some product which will inhibit our whole experiment or our whole chemical reactions. So it is making some product which will reduce our final product efficiency. Depolymerization of hemicellulose is required, because there are many kind of chemicals are there in hemicellulose, not a single. Removal of hemicellulose, yeah, it is also required if you just target some product which you get from the cellulose. Reducing the crystallinity, obviously amorphous is the much more reacted everywhere we see, because it is in a semi-solid state, and it is very easy to perform the reaction in the liquid form. So you can see, maybe picture is blurred, but landfill waste, wood, forest residue, all the lignocellulose biomass, bagasse crop, some kind of energy crop and all, out of it you are getting this main structure of lignin and cellulose. You have to go for the pre-treatment where you need to remove separate all these things. So in this pre-treatment, this is our whole first week 4. Okay, so Sanjay raised a hand. You can ask a question if you have any, or you can write it into the message also if you want. Do you have anything, Sanjay? Sanjay Jagirdar, or by mistake you raised a hand. Anyway, you can put the things in chat if you don't want to speak. So we are performing the pre-treatment. So pre-treatment will helpful for us understand these things to get into this kind of configuration from this. So we have now very easy access, and then after that if you do the hydrolysis, then you can easily separate all these things out. Okay, it's okay, fine, don't worry, Sanjay. So the pre-treatment are too much important. Why? From this structure it needs to be go to this structure. This same color is there. Wait, I just okay. So this structure needs to be converted into the means very packed structure is there, very crystalline structure is there. It needs to be converted into the amorphous and more accessible structure. So that's why we are doing all this pre-treatment. That's why you can easily chop it down, and we can ultrasonic and all this mechanical approach also we can use. And then after that we can do hydrolysis, and we can get the many different kind of products. We can separate it out, and then from that we will get the biofuel chemicals, pulp paper and adhesive surfactant, many kind of things out of it. So this lignocellulosic biomass, again it is there, And now I because deliberately I didn't attach too many slides from the internet. So main thing is the professor's slides are needs to be explained and understand. So that's why I chose the same slides. How critical to remove lignin and what is the acceptable limit? Okay, so first of all, this is an open-ended question, Hers. Actually, lignin is always prevent main generally 15 to 20% is the it also depends on the biomass to biomass, but the major biomass has 20 or maybe you can consider 25% lignin is this lignin in the biomass, all the lignocellulosic biomass. But sometimes if you find some hardwood or some forest wood where we find this lignin is up to 40%. Now lignin is it's not like that lignin is not useful, but the major chunk of our chemicals or final products are in the form of bioalcohols and biochemicals, which are we get from the cellulose and hemicellulose. Why? Because cellulose and hemicellulose has the glucose and fructose kind of thing, alcohol structure are there, and then alcohol from alcohol will get the fuels. That is a simple funda. Now how much critical? So it depends on the which kind of process you want, because this is very subjective, depend on your biomass. One thing, other thing is depend on your process. If you are going for some chemical process, then it's very important to critical to separate out the lignin. Why? Because if you use some chemicals, lignin are reacted with some chemicals and it will make some byproducts that will be detrimental to your final products. You will not get more products. So that's why when you go for a chemical treatments, lignin needs to be cut out. Another thing is, if you go for the physical treatment or mechanical treatment, so it will be easily you will get this lignin to it will be not if you go for the physical treatment, then it is easy to take out this kind of lignin and all. So that depends on your process and that depends on your final output also. So as you can see, if your cellulose and semi-cellulose, you will get biogas, biofuel, biochemicals like refinery, many things you are getting. But if it's not like that, lignin will be not helpful. But for lignin, you have to go for this pyrolysis, gasification and catalysis process where it requires high temperature. It's all a thermochemical process. It requires high temperature, and in case of anaerobic digestion, okay. So I can't claim any number or any amount, but obviously anaerobic digestion means we are going for this cellulose and hemicellulose into the fermentation process or digestion process when we are not using oxygen. So in that also we are using microorganisms and all. So lignin has some toxic chemicals also because it is a aromatic carbon. So aromatic hydrocarbon has some it will be lower down the efficiency of the microorganisms. If you are using enzymes directly for the digestion, then also it is difficult. So in that context, it is very critical to remove your lignin, but I can't tell you one particular number because you maybe saw the professor's slides. There are many different kind of processes. So but yeah, it is depends on the various factors. But yeah, it is very important to remove the lignin before you go process. But if you use cellulose and hemicellulose together, then it is not much more difficulty. But lignin is present, then it is difficult to you. What you are presenting, brother? So can you stop sharing your screen? Okay. So by mistakenly maybe you presented. Now I have to present it again. Okay, just okay. Maybe you can see my screen. We are here, I think. Yeah. And can you able to see my screen? In case of pyrolysis or biochar, Abhijita, it is very specific question. The pyrolysis portion of this subject will be covered into the future. But yeah, pyrolysis, if you are going with the pyrolysis process, then lignin will be, if you are using lignin, then lignin will be converted into aromatic hydrocarbons, that is for sure. And there are some pyrolysis process which is focusing on the lignin, so it may be not that much important for you to remove the lignin. Depending on your product, I am always telling that it depends on the composition of biomass and depending on your product. Someone want to say something? By mistake? Okay. So all these things we will cover, or if you want to go to much detail, then we can talk outside of this session, because this session will be recorded and go to the NPTEL team, and then from that it will be. So this is the fourfold purpose of this session is the for the assignment only, but I am covering the more things, so you this kind of questions will be we can discuss on this kind of thing. But yeah, we need to keep the time in your mind. But if you want to discuss, just I always have this my mail ID and WhatsApp number in the slides. At the last slide it will also there, so again I will put it into the chat box if you want. This is my WhatsApp number. If you have any questions which is not directly related to the current topic, so we can discuss outside of the class, and maybe I will not directly give you the answer, because I am also PhD student, so I am busy in my work. But I will go to it. I will get back to you. This is not the things that I know everything. I need to go for the research thing, and I am not working on the biomass area current means in my PhD research. I am not working on anything related to biomass. I am working on the hydrogen storage, energy storage, so I am too much into it. So if you want to learn that thing, then also you can talk me outside the class. But this biomass thing is not my forte, so I will learn myself, and we can able to discuss. It's not like that we can't do, but I will get back to you. If I will not get back to you now, then anytime in the future, so please pardon me. Okay, so pre-treatment method, this is we cover little bit hurry. I don't want to waste your time also, because your dinner and all everything will be there. So cellulose, hemicellulose has some products, and lignin has some polymers, aromatic hydrocarbons are there, which has the someone's mic is on. Please, Jainath, can you mute your mic? So it is making some noise in between. Can I connect on green hydrogen offline? Yeah, we can talk for that one. But even also, I am not working on the hydrogen production. I am letting you know I am working on hydrogen storage and transportation. So there are so many things. But anyway, we'll just focus on the biomass thing currently, which we are doing. So pre-treatment of biomass. So as you can see, pre-treatment of biomass, we have so many different kind of treatments. Professor covers so many things, so many information. But yeah, you need to understand why it is important. So chemical treatments are there: acid hydrolysis, alkaline hydrolysis, wet oxidation, organic solvents, green solvents. And from this hydrolysis also, raised a hand. So Jainath, if you are finding any difficulty, or by mistakenly because you connected by mobile. So look, one thing, if you can't able to see the screen into the mobile currently in the live session, you can leave this meeting. I will upload this. I will edit this video, recording and upload this by tonight only in the YouTube, where you can easily watch. If you can't, and the laptop and all, it's up to you. If you want to have some questions, you can take it. It is not any restrictions that you have to cover and you have to stay. All the lectures recordings will be there in the YouTube. Anytime in the future you can see it. So then the physical, grinding, milling, microwave, ultrasounds are there. Biological, lignin degradation and cellulose degradation. And physiochemical, steam explosion. This is an important process. Supercritical and supercritical fluids. Supercritical fluids, it's a very important area nowadays. Supercritical means which is you are going for the more than high temperature, more than critical temperature, more than critical pressure. If you are going to that thing, that condition, physical condition, then it will convert into supercritical. CO2, if you just consider more than 65 bar pressure, if you go, then it will be on the supercritical, around 10-15 degrees centigrade. then they have the very different kind of characteristics which you can use it. So these are the some this is the slide from the professor. Physical extrusion, you just give the pressure and you find a pulse electric energy, you give some electric shock, it's not like exactly shock, pulsation, the pulsation, or some kind of vibration you are providing. Liquid hot water, pyrolysis, irradiation, mechanical and grinding, milling, chipping. Chemical, this is a major class. Alkali treatment, acid treatment, oxidative treatments, where oxygen, ozone treatment is there, peroxide treatment is there. We will not cover each and everything, don't worry. These are the some slides I put it together because it has some questions. There are some questions on this basis of these slides in the assignments. Solvenolysis, where we are using the hydrolysis in the presence of solvent. So diptychtic solvent is important. Hydrotrophs, and liquid is the one. Salts. These all are at the research stage. That's why there are many things. If it will come into commercial stage, you would not find this many classification. But in the research stage, still it is there. Once you will in the future will finalize the commercial technology for all of this, then we'll, because everyone doesn't have the same economics, considering the same biomass and same product, economics are always different, and depending on the products, the process is also different. Physiochemical, steam explosion, ammonia fiber explosion, ultrasound assisted chemical pretreatment, microwave assisted chemical pretreatment, microwave assisted pyrolysis, and combination. So this is where you are using these mechanical processes like with ultrasound, microwaves, this is a thermal radiation which you are providing, which you are using microwave one also. Ultrasound is the sound which is more than 20 kilohertz or megahertz, I don't know exactly, but more the frequency is more than 20 kilohertz, which generally we can't able to hear directly. Human ears are not acceptable to heard this amount of voice or sound. But whales, dolphins, and sharks are using this ultrasound technology. We are using sonar technology, is a similar kind of this, and bats also using biological process, where we are using enzymes which are directly reactive, some chemicals directly reactive into the products. We have some microorganisms which we are doing all this work, and this microbial consortium is more than 2-3 different kind of microorganism which can be easily work together to get the products, same in the different manner. But here you can say various combinations is also mentioned. This is just more than what you have in professor's lectures, but it is just for the information, don't worry. Now this is selected exam for enzymatic pretreatment. So okay, what is this? So I just cover these two different tables from the professor's slides because there are some questions into the assignment based on this, that's it. So enzymatic pretreatment, if you are providing for the lignin degrading microorganisms, so these are the inoculation means microorganisms when they work for the culture, means culture in the sense biomass, and they do some reactions, and in that period of that reaction of in the presence of microorganism has name inoculation in the biotechnology. If you read the microbiology of biotechnology, the name is inoculation period or the inoculating period. When lignin degrading microorganisms, so various types of lignocellulosic biomass. So these are some microorganisms which can be helpful for the lignin degradation also. So white rot fungus, soft rot fungus, brown rot fungus. These are the fungi. Okay, so fungus which we are using. And which kind of microorganisms? These are group of fungi. And this kind of microorganism is there, and this is the biomass feedstock. So these are some data: 30%, 20%, 40%, 80% increment on the or degradation of this lignin content, degradation of cellulose content. So this you can go to it. These are some the fungi. This is also microorganism. You have some bacteria, which is also microorganism. You directly use some enzymes, which we also in the human body also we are using some enzymes. Or you can see that dahi, curd or yogurt is converted from the milk to yogurt by using the lactose and all. So please mention your email. The number is your WhatsApp number or not? Yeah, it's my WhatsApp number. My email is there under the first slide of this lecture, and at the end of the lecture also I am again mentioning here this email. So this, please use this email only for the communication. It is my specific email which I am using for this NPTEL one. Okay, so this kind of enzymes which we can directly use: lacase, lignite peroxides, and manganese peroxides. Now these are the producers. Sir, can you also provide the link of channel where you will upload the recorded lecture? I am not uploading, brother, the lecture. Sorry, I thought that the same person asked. Abhijita, I am not uploading, Abhijita. Actually, okay, give me one second. I will show you where it is. Or you know this NPTEL lecture link, na? In that itself you will find the video links of all the lectures. But if you want to see, we just see it. So we can go to the Google. I don't know it's how much easy for me currently. Yeah, this is the biomass conversion and this is a lecture and everything you are getting. So here first you can confirm that can you able to see the screen. I just opened the online Swayam portal. Can you able to see the screen? Yeah, Abhijit. Okay, so here different, maybe this is the last one, last week one, so you will not get week 4 content, but in this problem solving session is there. So if you just, okay, so I need to again, give me 1 second, need to again log in. Okay, so it got login. So yeah, this is currently whatever you are seeing. So if you go to the problem solving session, so in the problem solving session you will see the click here to view the problem solving session lectures. So if you have to just click here, now you will get two different kind of TA names, two different kind of lectures. Okay, one is Arihant Ahuja and another is a Bhavik Kumar Mohan. So I am Bhavik Kumar, I am Bhavik, and another guy is Arihant Ahuja. So you can get this presentation by just clicking on this presentation folder link, and YouTube videos are there. So one person is taking the similar kind of lecture on Friday, and I am taking on Tuesday. He is from IIT Roorkee and I am from IIT Madras. We both are the PMRF scholar. That's why we are performing this thing. Anyway, it will be not much important for you, but yeah, you can get all the lectures, everything over there. And once you get the lecture video link, that will be the channel. Okay, so we'll discuss all these things, research and all, outside of this class, because it will be not helpful for this thing. Sorry, because this all thing will be go to the NPTEL. So this you will get to know our channel also from there. So you can directly access this channel. So all these things will go to the next thing. Now the pre-treatment. So I will not cover many or any kind of pre-treatment, but I just glance through the major pre-treatment. Maybe there are some questions on in assignment, so we'll just go through it, just glance through it. Okay, so mechanical, obviously we have the milling, grinding, chipping, extrusion. Now what is a pre-treatment? We have the packed biomass, suppose you consider, and we just have to slightly releasing the amount component, and to somewhat like you can see, consider that the very highly packed material, and you go to the semi-solid kind of thing, and then you will do the hydrolysis. So after pre-treatment you will get to separation of some of the material. It's not directly separation, but yeah, it is in the form where you can go for the next stage of reaction, when you can go for the hydrolysis, and from hydrolysis you will get all the three components differently. So pre-treatment is this step. Okay, always remember, you will not get any product out of it. It is the one step which is required to convert your first hand of biomass into the more accessible to the chemical reactions or thermochemical parts. So extrusion, we are providing this kind of force, and you will get a product out of it. Ball mills are there. All we know in the mechanical operations we are using all these processes. Now this is the important slides. Maybe you will get some questions also. So hemicellulose removal. So for that alkaline treatment, oxidative acid treatment, this blue portion will cover. So these three major part of the treatment which will be useful for the hemicellulose removal. If you go for the lignin removal, then except acid treatment you can go for any kind of process. For cellulose removal, maybe alkaline is also there, I think. Ionic liquid, deep eutectic solvent, and this. And now what are these organosol, deep eutectic solvent, ionic liquids are there. We'll not go into detail because we don't have time. You can just watch a professor video, or you can just refer to his lecture notes. So mainly for lignin removal, we have many kind of treatments. So our focus is on to the merging this lignin remover with another helpful product, either it's cellulose or hemicellulose, and then we can go for the pre-treatment process depending on our product also. Now acidic pre-treatment, where we are using acid, one of the most effective method okay, for the pre-treatment of lignin. But here you see acid will be not in the lignin part, lignin remover, it will be not helpful. But although acid, we are using concentrated and diluted acid to break the rigid structure of the lignocellulosic material. So this will be the helpful treatment, but the main thing is, this is the reactions. Main reaction during acid treatment are the hydrolysis of hemicellulose. So we are doing the hydrolysis of hydrolysis, where we are adding the water into the any kind of material in the presence of acidic medium. And first step, we are doing a hydrolysis of hemicellulose, and then condensation, and at the end precipitation, where you are getting the lignin, because lignin is not reacted, so you will get at the end of the form of precipitate. The most commonly used dilute sulfuric acid. They are concentrated and dilute, both kind of treatments are available, but according to the professor's lectures, dilute acids will be much more helpful. Now organosol method. So organosol is nothing the organic solvents. They just club the organic solvents, two words, and convert into organosol. So where you have the various organic or aqueous organic solvent, obviously. So organic solvents all are in the form of aqueous only, mainly liquid form only. You have this for the if you just want to see the example, then alcohols, methanol, ethanol, acetones, ethylene glycol, triethylene glycol. These are the much more common available industrial organic solvents. And then tetrahydrosulfur alcohol. This is also commonly used in the process, but this is not that much common to availability. But these alcohols and ethylene glycol and all you will get everywhere. So organic acids such oxalic acid, salicylic acid. So these are the all the organic acid. Oxalic acid is generally COOH. It will not require, but I just tell you for your, if you have one carbon in no carbon, then oxalic, one carbon, then succinic acid. But this is a salicylic acid, and it has some here and there. But we don't need to go to that much detail. It will be no helpful. But you have to go to the treatment of lignocellulosic material with the use of alcohol leads to hydrolysis of the internal bonds of lignin and hemicellulose. Here lignin and hemicellulose both are reacted with this, and hydrolysis can be done, and this hydrolysis is converted into ether or ester interpolymer bonds. We already see how ether and ester interpolymer. So how we can convert into ether and all, we just see through the polymer. We didn't see, we saw in this same lecture. So we don't go into much again same detail. Now the pre-treatment of lignocellulosic biomass using ionic liquid. So there is one class, ionic liquid. I will not cover anything. I'll just take one thing. So this is two different kind of liquid come together. Ionic liquid, one is a negative charge, one is a positive charge, and then you first it will start from the lignocellulosic biomass per ionic liquid, and then you will get this fractionalization pre-treatment, and after that you will get a lignin separately, and you will get the cellulose separately. Then as we discussed, from lignin precipitation you will also again separate out hemicellulose, and from lignin you can use it into the biorefinery to get some products. But cellulose you can use it in the many different processes like fermentation to get ethanol fuel, bioethanol. Other than that, the first so first is this is also the way. Okay, this is a similar way. Here you can directly use this This is also types of ionic liquids, and this is going to dissolve biomass, that is also converted to cellulose, and other is you can go to finer processing where you will get the sugar. It's not that much complicated, but this is a separate part. This is one hot separate channel, this is a separate channel. So out of your product you will get a different kind of products. And the another method is a deep eutectic solvent. There is one assignment question also. A deep eutectic solvent is you have two different kind of material. One is a hydrogen bond acceptor, one is a hydrogen bond donor. So when they come together, here in the ionic liquid, positive charge and negative charge, here you will get hydrogen bond acceptor, so which can form the hydrogen bond, and another is hydrogen bond donor, which has much more hydrogen there at the outer layer of this molecule, and it compounds with a melting point much lower than that of the individual component. You will, when we combine those together, then you will find the deep eutectic solvent, which has a much more lower melting point. An application of DES for pretreatment of biomass is alternative to conventional ionic liquids, especially due to their lower cost. Now this whole ionic liquid things will be much more costly and expensive. So if you are using this deep eutectic solvents or something, then it is we are using this urea, CuCl kind of material, which is we are using as an industrial chemical in a lot. The synthesis of these easier to DS can be obtained from widely available inexpensive ingredients. Okay, so next thing is from the same DES. So the electromagnetic field of microwave leads to break down the biomass structure, mainly due to the molecular collision caused by the dielectric polarization. Now, if you provide in this DES microwave also, microwave we just see that mechanical process, we can use microwave, ultrasonic and all. So if you are using microwave in this same DES process, then it will be helpful. How? So it increases the molecular polarity of DES. Okay, so you have hydrogen bond acceptor and donor. That means two different kind of molecules are there. So in your biomass, if you are using microwave radiation, then biomass also molecular polarity is DES microwave polarity is again enhanced, and that will be enhance the efficiency of pretreatment. How it will be take place in a simple example, if you take it, then in DES, suppose it will be not like that, but we consider one part is positive, one part is negative. We have biomass, some in that also different kind of things are there, positive, negative charge, so many things are there. So negative will be directly reactive with positive and will get some kind of product, and positive will be reactive with negative and you will get some kind of product. This is not exactly how it will be take place, but this is for the understanding point of view. Pretreatment biomass solve a 2 to 5 fold increase in digestibility during enzyme. So this pretreatment will be going to the next hydrolysis process obviously. So if you are using this microwave and this DES process, then you will get 2 to 5 fold increase, I mean 2 times to 5 times more digestibility when you are using the enzymatic hydrolysis. Okay, so this is a lignocellulose, cellulose, lignin, hemicellulose. You have DES made of lactic acid and CHCl. After this pretreatment, you can recover the lignin and all after hydrolysis. This is the whole how this microwave assisted DES pretreatment will take place. Okay, I think 2-3. Okay, last slide. So I will not bore you more, guys. So we'll complete it. So the pretreatment of biomass is, there is one. There are so many I didn't cover, and actually I just covered whatever the important for the assignment questions. But yeah, you can go through the professor's lecture because it can't be covered into the 1 hour lecture or some 1.5 hour. So we have biomass. This is a sequential acid and alkaline matters. There are acid pretreatments are there, alkaline pretreatments are there, but this is most generalized one. When we go for the higher productivity, then we first go for the acid hydrolysis, you will get the pentosis. Then again this acid treatment biomass, again go for the alkaline extraction, you will get the lignin and crude cellulose. So all things got to be clear. This pentosis means hemicellulose. Hemicellulose has pentosis, hexasis and more polymerized structures. So hemicellulose is separated out. Lignin is not whole hemicellulose, maybe some hemicellulose will go into the this lignin also, and then crude cellulose. This is the cellulose, lignin, hemicellulose. These are the biomass, and these are the some results which will not that much we need to remember and all. This is just comparison of acid alkaline hybrid acid alkaline pretreatment. The mild acidic biomass pretreatment is high recovery yields of each biomass. These are advantages, disadvantages. Possibility to use all kind of biomass, low energy, low chemical cost and all, because acid itself is strong material, so it can easily degrade the things. But it has required long processing time. 2 processing steps are required. Greater equipment requirement. More research needs to be done. Now this alkaline work industrial pulping process, then it is a short processing time. It's simple processing steps. Efficiency for cellulose is more, and process technology is well defined. Go for the highly concentrated processing media is disadvantage, because concentration is much more high. It will be reduced or some kind of products if it will react with the alkaline material. Low yields of cellulose, high volumes of liquid, generation of polyethylene residues. But if you use sequential, then recovery of hemicellulose, sugar, lignin and cellulose, everything which will be easily recovered. It enhances enzymatic digestibility and fermentability. But it requires some additional step, additional expensive is there, more research needs to be done. Still everything is at the research stage, so more research needs to be done. Okay, so at the end I am leaving you guys. If you have questions we can discuss after this. So this is my mail id, and with the thought of CV Raman, that this just I have a habit to put it at my all the presentation for the motivation of myself. Not I am not here to motivate anyone. So the famous thought of him is, I am the master of my failure. If I never fail, how will I ever learn? So mainly we are impose our failures to sometimes to the situations, to the in the whole life, not only the exam, to the someone, some friends or some parents or all. But I am only the responsible. I am the master. If you want to learn, so we can fail and we can learn easily. So with this I just want to stop my sharing. If you have any questions you can ask, otherwise you can go for your dinner and have a good evening and good night. Anyway, you don't need to tell us a thank you. It's because it is our duty. We need to, if someone is there in our responsibility, we need to perform it. It's not like that. This PhD process is whole, it's like a job only. I was in industry before, and now also I'm in PhD. I'm doing so many works for getting the stipend. The same thing, I need to go for my salary. So these are my work or responsibility which I need to perform. Okay. So Abhijita and Jainath Prasadji, if you have any questions then you can ask me, or else I already have shared my WhatsApp and mail details. I am just telling you, maybe I will be more available on weekends than the weekdays. So if I want reply you, or if we can able to discuss in the weekdays, so Saturday Sunday I will be available. You can directly call me also, it's up to you. Yeah, thank you so much. If you don't have any further question you can leave, both of you can leave. I am also leaving. I am stopping this. Yeah, so I'm putting this.